So in this video, we're going to talk about naming alcohols. And alcohols are, general, you'll see them with some sort of R bonded to an OH, which is just in the hydroxyl group, right? So a regular alkane, right, this would be butane, right? But now our parent changes, right? The parent changes if we have an OH on that, normally what you would call butane. So this would be butanol, right? So you could imagine we kind of replace that ending with an ol, this OH, this OL, right? So when it comes out to naming these, compounds, we change the parent, obviously ending in O, like O, ending in OL, right? But also we got to give the location of the alcohol. So let's look at this molecule. Right, so we have a molecule like this, right? So how would we name this molecule? Well, again, the alcohol, you want to give the alcohol the lowest number. So you always got to give the location of your lowest, the alcohol, you know, the lowest number. So we could start from here and say, okay, this is carbon 1, 2, 3, 4, 5. Or we could start from here and say this is carbon 1, 2, 3, 4, 5. So obviously it would be better to start from here, since that gives our hydroxyl group, number 2 instead of being at number 4, right? So with that being said, just list our substituents as usual. So this would be carbon 1, 2, 3. So here we have a 3-methyl, right? And there's no more substituents, right? So putting everything together, this would be 3-methyl dash 2-pentanol, right? The longest chain is 1, 2, 3, 4, 5 pentane, but because we have this alcohol, we give the location of the alcohol, and then we just replace that E with that OL, which would be pentanol. So how about this one? So how would we name this molecule? Well, again, notice that we have an alkene and an alcohol, but still the alcohol gets the lowest. This is our parent chain, and so the alkene will be a substituent in this matter. So we wouldn't start from here and say, okay, this is carbon 1, 2, even though that gives the alkene the lowest possible number, but this is an alcohol, so we got to take alcohol gets priority. So we could say this is carbon 1, 2, 3, 4, 5, 6, 7. So the parent chain in this case would be heptanol, right? And now we just list our substituents accordingly. So we could see in carbon 1, 2, 3, 4, 5, we have 2 methyl groups. So this would be 5-methyl and then 5-methyl, all right? So those are 2 substituents. Now in carbon 6, we also have a methyl. So this would be 6-methyl. And then in carbon 6 also, we have a alkene. So this would be 6-ene, right? And this is how you kind of name alkenes as a substituent, right? The number and that E-N-E, right? So at this point, we've taken care of all our substituents, right? So let's put in this name. Let's put this name together. This would be 5,5,6 trimethyl dash 6-ene, right? And then we just put the location of our alcohol, which would be dash 2 heptan. Kind of running out of space here. Heptanol. So this is how you would name this compound. And now a lot of people will say, okay, well, why did the methyl groups come before the ene, since E comes before M in the alphabet? Well, this is kind of just a gray area. And usually when naming compounds like these, you wouldn't see 6-ene, 5,5,6 trimethyl heptanol, 2-heptanol. Usually the obvious substituents comes before the naming of or the position of the alkene carbon-carbon double bond. All right. Now, when it comes on to cyclic molecules, the alcohol always gets priority group number one. So this is actually cyclohexanol. And we could, for educational purposes, this is actually one cyclohexanol, but we don't need to write the one. But for cyclic molecules, your OH groups always get number one. So how would we name this? So how would we name this compound? Well, remember, our OH groups always gets priority group number carbon number one, right? So you could imagine this would be carbon number one. Now we could go around here, we could go around here, but remember, which one gives our substituent the lowest number possible? And we'll be counting this obviously in this direction. So this would be carbon 1, carbon 2, 3, 4, right? So you can see on carbon 2 we have a 2-bromo, right? And carbon 4 we have a 4-methyl, and that takes care of all our substituents. So putting everything together, this would be 2-bromo dash 4-methyl, and then our parent name, the cyclic, right? So this is cyclo. Usually this would be cyclohexane, but because we have an alcohol, this would be cyclohexanol, right? And this would be the naming of that compound. Now, with alcohols, you also have, you'll see compounds like these. A cyclic molecule, an aromatic ring bonded to an hydroxyl group, and this is called a phenol. This is in organic chemistry, we call this a phenol. Anytime you have an aromatic ring bonded to a OH, we call it a phenol, right? Or phenyl, whatever works best for you, right? So how would we name this molecule? Well, again, remember with cyclic molecules, your OH always gets carbon number one. So this should be carbon number one. And let's see, where could we count to get the lowest priority group for that chlorine, or the lowest number possible for that chlorine group. So we could say, okay, this is 1, 2, 3, 4, or 1, 2, or carbon 1, 2, 3, 4. In this case, it doesn't matter. So putting everything together, this would be 4-chloro dash 1 phenol. Now, we don't have to write the 1, right? So putting everything together, this would be 4-chloro phenol. Now, some teachers like it this way. Some teachers might ask you explicitly to put that number 1 for the phenol, but it's not. Either way is correct. Either way is correct. Either way is correct. And this is how you name alcohols.